In this lecture on numeracy skills, I'd like to deal with the issue of gender differences and mathematics, and students' confidence when they take on this discipline. Imagine that you see a young Japanese girl, and she says konnichiwa, or possibly an entire sentence in Japanese. You're unlikely to think to yourself, oh my goodness, she can speak Japanese, she must be a genius. Because Japanese is the language that she was born to speak. She's not necessarily more intelligent than you, it's just that she understands a different language. I think many people are intimidated by mathematics because of the mysterious symbols and equations, and possibly because they don't appreciate that this is merely a different language. So I suggest that we approach mathematics as we would approach learning a new language. I think that the basics are fairly easy to grasp. Once you then grasp those basics, the whole thing becomes slightly less daunting. As with learning any language, the more you practice, the better you get. And yes, it's hard to be fluent, but guess what? You don't need to be. Now, math inferiority, I think, is a real problem, and it's a real problem especially amongst girls. The reason why I'm emphasising gender differences here is because in my experience it tends to be female students that have the biggest difficulties when it comes to learning maths. And when I found out that I was having a daughter, I did some reading on the subject and learnt a great deal. I think that gender differences might affect where we start in some situations, but they don't need to determine where we finish. And there's a lot of confusion about the role of gender in things like mathematics. The classic example is the Barbie, which when you pressed a button gave a list of various phrases, one of which was math class is tough. This tapped into a stereotype that females struggle more with maths than males. There's a video at the bottom which you can have a look at. The stylized facts are that on a standardised test, the SATs, males tend to get higher test results than females. According to Mark Perry, it's well known that for the SAT mathematics test, male high school students in the US have higher scores on average than females. The gap is large and statistically significant, and the male-female math test score gap has persisted over time since at least 1971 and probably much longer. One possible explanation for this is the fact that males tend to produce outliers at both tails of the distribution. What this implies is that we may have a situation where when we look at the very top of the distribution, there's more males than females. It also means that at the bottom of the distribution, there's more males than females. Now, it's plausible that males are better suited to some things. This is evidence to suggest that males are better suited to combat than females. These are scientific studies that suggest that males tend to have greater upper body strength, taller bodies, heavier bodies, higher basal metabolic rates, faster reaction times, etc., etc. However, there are multiple explanations for SAT scores that go beyond the simple claim that males have an innate advantage. One issue is socioeconomic status. It may be the case that socioeconomic status is the most important predictor of SAT scores, and systematically more girls from low-income households take the test. Therefore, the test results are picking up on the socioeconomic status rather than innate gender differences. There could be an issue to do with risk preference. The SAT penalises wrong answers. Therefore, if you're not 100% sure of an answer, there is a gamble involved. The decision is whether you guess. Evidence suggests that males might be greater risk takers during tests. And therefore, if risk-taking plays a role in the exam, males have an advantage that is completely unrelated to their knowledge of the material. It's purely their greater risk-taking that is leading to the higher result. We need to be careful of stereotypes. This demonstrates a math test score and the difference between males and females when they were told that no gender difference had been found on this test. As you can see, the men slightly outperformed the women. However, when the men and the women were both told before the test that gender differences had been found, then the men's score was significantly higher and the women's score was significantly lower. Similar results apply to other stereotypes as well. If you make non-white males aware of a negative stereotype, it can affect the result of that as well. We also need to be careful about which role models we choose. According to Lisa Elliott, mothers who turn their maths homework over to dads send daughters a covert message about who's good at the subject. She also reports that secondary school girls do indeed perform better in science classes taught by women teachers. A positive mindset can make a big difference. At primary school age, females slightly outperform males at computation, according to some studies. Lisa Elliott says, girls are simply more reluctant to think of themselves as smart, and they believe that they do well only because of greater effort, while boys think just the opposite. Again, the explanation here isn't the ability at the particular subject, but it's the mindset that distinguishes between females and males. The conclusion is that a lot of test performance may well be down to confidence and anxiety. Consider the following pattern. 1. Different kids with different levels of preparation come into a math class. Some of the kids have parents who've drilled them on math from a young age, others never had that kind of parental input. 2. On the first few tests, the well-prepared kids get perfect scores, while the unprepared kids get only what they could figure out by winging it. 3. The unprepared kids, not realising that the top scorers were well prepared, assumed that it's genetic ability that was determined the previous performance. They decide that they just aren't math people, they don't try hard in future classes, and they fall further behind. Step 4. The well-prepared kids, not realising that the B students were simply unprepared, assume that they are math people and they work hard in the future, cementing their advantage. What can start off as a subtle difference in mindset can become a self-fulfilling prophecy. The brain is a muscle though, and it gets stronger with exercise. The hippocampus is the area of the brain responsible for spatial navigation, and there's evidence to suggest that London cab drivers, who are required to acquire and utilise complex knowledge, have larger hippocampi than the general public. Not only this, there's evidence that the size of grey matter increases as drivers became more experienced. There's also studies that suggest that even a few weeks of cognitive training can increase IQ scores. So whether you think you're bad at math or not, the good news is that we can change this. But in order to change it, we need to want to change it, and we need to recognise that we can change it. The good news is that stereotypes are changing. In the 1970s, under 10% of veterinary scientists were female. By 2009, 74% were. Around 9% of accountants were female in the 1970s, compared to 61% today. As a male, and somebody that doesn't think of themselves as naturally gifted at maths, I've tried my best to overcome this through practice and through learning. However, I also think it's important that we pay particular attention to females and to try and make sure that females realise that there are not innate differences that dictate and determine how people end up in mathematics, and that disciplines that are based on mathematics, such as engineering and science, are equally open to females and to males. Here are some examples of famous female scientists who perhaps deserve wider recognition. Perhaps if they did have wider recognition, some of the problems mentioned earlier in this lecture would cease to exist.